Hello, everybody. I'm Sergis Verdaguer from Lima Association and Progetone Project. Progetone is a new funded project developing new solutions to increase energy efficiency and the seismic safety in the building sector. Today, we continue with our last webinar, where we will debate around the digitalization of the building sector and how the use of different tools, digital tools, can enhance the decarbonization of our building stock. So to talk today about that, we have invited three experts in the area. First of all, Elena Pla from the Institute of Technology Construction in Catalonia. We have also Arnau González from Aiguasol Consultancy, also in Catalonia, and Andrea Ballaveni from the University of Bologna in Italy. Unfortunately, Andrea has a last-minute issue and he will not be present directly, but he has sent us a video explaining his presentation. So after the two presentations from Elena and Arnau, I will present the video from Andrea. So remember, we have initially some presentations, the three presentations from the experts, which will last probably less than 10 minutes each. And then we have a final roundtable where we have some common questions that we can put to the different experts. If you have any question, please put on the comment section, and we will try to ask the experts. So with no more delay, I will let Elena to present his presentation.
Hello, good morning. I will share with you my screen now.
Yeah.
Thank you. Thank you. Okay. So, good morning from Barcelona. I'm Elena Pla. Do you hear me? Yes?
Yes, perfect.
Yes? Okay.
Thanks.
I come from the Catalonia Institute of Building Construction. I am an architect and I've been working in BIM development since 2014, and we are dealing with BIM tools and digital tools for a long time. So we are placed here in Barcelona. We are, let's say, placed in the eye of BIM. We say this, in the eye of the information dealing with management, with market research, with sustainability, with digital transformation, databases, and certification and assessment of building materials and products. So all this mixed together, when BIM came, we knew we already had some ideas of how to handle these digital challenges that BIM was setting. What is, in a sense, BIM? I imagine that most of you are aware of it, but just in case there was something somebody didn't know, I wanted to point out the main idea of BIM. The main idea of BIM is a digital method to convert, let's say, the ideas and to project and develop the projects in the digital environment. Let us say that we have the physical environment, the atoms, no? We have the first idea of the project, which is to do a plan, to plan it, no? Let's do a school, let's do a building, let's do a stadium. Okay, we have these atoms, we take these atoms, we plan them, and everything is done in the digital world, besides our heads, of course, and we design and we build together, and we get to final products, the physical product, which is the most important product and the final goal, but there is also a digital twin, what is called the digital twin of this final product, which will afterwards help and ease the works of managing the physical product. So this is in essence the BIM process of or the digital transformation in the building sector. And we must be aware that there are two products to be delivered, the physical one and the digital one. No one should think that there's only digital, or no one working in the middle states or stages should think that only the physical is to be delivered. So both of them are equally important. Okay, and what does it mean if we go, let's say, inside this design or build part? How do we work there? We can work with the BIM models enriched with digital, with data, with all sorts of data, of all sorts of structured data, and together what we do is to enrich them and complement them with the digital databases that we already had and which are very rich and complex to handle themselves, and that they cannot be fully integrated in the BIM models, because BIM models have limitations. Some elements are not model or whatever. So we do this complementary work of databases with BIM models, or let's say BIM models with databases. So we have this dual digital world. This is how we work. Uh, um, the, everything can be already done in manufacturing things. The manufacturing industry is already digitalized, no? So how do we convert this physical item into a digital thing? With technical properties. Everything should be inside the digital model. This is the challenge. How do we start working? How we convert this into bits? Let us say the first bits that we think of are pictures. No, if we look in the Pinterest, we can see this kind of facade. But these bits, this information, this digital information, isn't the only one we are interested in. We are also interested in geometry, in drawing our ideas and converting them and integrating our ideas with the technical specifications of the manufacturers, which is not the same. I may have an idea, but maybe it doesn't fit the size of the tiles or the color or the kind of material. Maybe it doesn't fit with the manufacturer's definitions. So the challenge is that we can count on the CAD drawings of the manufacturer, and we can also count on the CAD drawings of the design team. No, so at the end, that facade can be converted into this. And when it comes to the BIM objects, we should also think of integrating the technical properties coming from generic items or regulatory conditions that we may have. Everything can be integrated, so the result are these BIM objects with structured information. And the structure of this information is also a tool, a very useful tool that you can count on, which is a COP standard, which is a standard for creating BIM objects, which defines how to name the properties, technical and management properties, and how to define the values. So at the end, with these objects, what are we going to do? We have this 20th century plan, but in the digital momentum that we are, this is the way we should do it now. So every project should be digital in these terms. And this allows us to compare, for example, if I have everything and every kind of of wall or facade structured in the same way with the same properties. And I can compare. This helps me to compare. I can compare anything that has been introduced in the BIM object besides the geometry. The geometry is already there, the thickness of the wall, but there I also can compare the energetic cost if I have it, or the CO2 emissions, or the price. So this would be the bunch of tools that we are working with. We have our BEDEC database of building elements. We have BIM libraries. We have ECOP standard, and we have these programs TCQ and GMA, and a viewer of this. So we have all this bunch of tools, and with these tools, the result is that at the very end of the project, you can have element by element the amount of energy and CO2, for example, emissions. But altogether, I can also have the whole big budget. And afterwards, I can pour this data into the BIM model, and I will get this data well structured in the BIM model. So what do we get at the end? I get the geometry of the project in a digital shape, no, in the digital model, and enriched with data, with valuable data that may help me to do a well-informed decision in the project. More or less, I tried to be very quick. This is in essence what we are working in. And if you want to deep better in the concept, because I went too quickly, maybe you can ask me whenever I feel free to ask me whenever you want, or send an email. Thank you very much. Kind regards.
Thanks, Elena. Thank you very much. Very interesting introduction to BIM possibilities and what we can do with this digitalization of the building elements. So now, Arnau, the floor is yours.
Thanks, Agis. Let me just share my screen so you can see it well. Okay. Now, let me just start from the beginning. Okay, can you see the screen well and hear me well?
Yeah, perfect.
Okay, thanks, Agis, thanks, Elena. Today I'm gonna present a development that we're working at IWasol with from a couple of years now. It's at the point of being a usable tool now. We called it Circularity Tool. This is kind of the naming that we that we came up during the development, and this is intended to be a kind of a decision support system. That's what DSS stands for here, for building circularity at design phase. The idea is that this should be a tool, or this can be a tool that can be used at design phase to inform decisions regarding the building design to make it more circular. So first, I'm gonna shortly introduce who we are, as Elena did before. IWasol is a small consultancy firm based in Barcelona as well. We are 25 people right now, and we are doing and carrying out a couple of projects related with buildings, energy efficiency, and renewable energy generation. Also, urban. We have a urban approach as well, so we kind of do projects related with urban planning, related with energy, things like district heating networks or energy communities. And we also work in industry and energy intensity in industry to make it more adaptable to climate change and less intensive on CO2. So that's our focus. So we have, as I said, different areas of expertise. I'm gonna pass that quick and focus on stress that we have a small part of our work which is applied research and development, and the tool that I'm presenting today is has been developed in research projects, so that it's kind of an applied R&D solution itself. So, as I said, we are approaching our projects taking into account energy consumption from different vectors, so for electricity, heat, cold, but also we integrate, and that's important here today, data management into our projects in several aspects. One of these is the development of digital tools that can help designers and practitioners to inform their decisions and do better designs. So the two projects that I must stress today is one is Plug and Harvest, which is a project that is finishing this year, focused on the development of a circular facade solution for the renovation of residential buildings. And the other one is Houseful, which is a project focused on the development of several solutions, a set of 11 solutions. One of these is the circularity methodology that informs the circularity tool that I'm presenting today. So with the work of these two projects, we have been working in the development of this approach from a methodological aspect first, and then converting it into a digital tool based on a web environment, so it can be used by end users easily, no? And only with access to internet connection. So how do we see circular economy? And this is the basis of the methodological approach that we implemented. According to different definitions and the frameworks existing, we and also taking the approach of the Houseful project, we wanted to evaluate circular economy obviously from a holistic perspective, but focusing on in detail on the materials, water, waste, and energy vectors, which are the ones that will create the more relevant material or natural resources flows in building construction activity. So this is the most used natural resources when building and operating buildings. No? So our approach comes from the detection of the necessity of focusing on building circularity from a broader aspect than materials itself. No, there are many experiences working on materials circularity evaluation. Materials are important, are obviously one of the most important, if not the most important aspect when designing a building, but taking into account the whole operational stage of the building, energy aspect becomes critical, also water uses, and we also wanted to focus on different impacts, no? Like social impact, environmental impact, and economic impact. No? So this is aligned with current approach of levels framework, from the European Commission that most of the attendants will know for sure, and is also aligned with current standards in building when sustainability of building construction works that advise to take into account all the life cycle from a broader perspective, from the product stage in which the products that will conform the building are manufactured, to the construction stage, which is a very intensive consuming resources stage, and also the user stage, which is critical because a building is usually designed to last, no? To last 50, 100 years. So all impacts in the user stage become very relevant when taking this life cycle approach. And obviously end of life processes, which means deconstruction, residues treatment, and disposal, and so on. So our methodology and the tool that I'm presenting evaluates the circularity with 6 different indicators. 3 are flow-based indicators, which are the materials, energy, and water. These are indicators that basically measure the degree of or the rate of circular flows into your building activity, to your building construction and operation activity. So we perform kind of a life cycle analysis, but a flow analysis in which we see how much of the energy is consumed and how much of this energy comes from circular sources. Same with materials or water. And we also incorporate three different impact-based indicators. We call it impact-based because these are the indicators that somehow relates to the current standards and the three aspects of sustainability, social impact, environmental impact, and economic impact. So we are aligning our methodology with the current standards and regulatory framework from the European Union. And what does this tool do? This tool basically performs a 6-pillar assessment in which we evaluate and provide the results to the end user with the rate of circularity in energy, in water, in materials, in social impact, in environmental impact, and in economic impact. Then, and we incorporated here, and the tool also does that, is a regional assessment to weigh the relevance of these circularity indicators. The idea is that different regional or country or different countries or regions might have different stresses in natural resources. So it's not the same or not that it doesn't have the same relevance the water savings in Southern Europe that have drier climates than in Northern Europe, more rainy, and it might be the other way around with energy. For instance, in places with lots of renewable energy available, no renewable energy sources available, like solar irradiance or water flows, stream flows, then you might not need that reuse and circular approach with energy because you have plenty of resources. I'm not saying that it's not important. The thing is that we want to weigh in the different relevance of the different aspects and stress which ones are more relevant in your particular region. So we are evaluating all the all these 6 vectors, but then we are weighing in the relevance of each one and stressing and giving more value to one or the other, depending on on your regional the place on which you are building or doing this project, no? And then this is important because at the end we want and we think that this is something important that we came up when developing the tool. We want to give a kind of a score, no, like a certification scoring for circularity that could be similar or similarly understood as the energy certification of buildings, in which a building with good rates of circularity would get a higher score, or like an A certification of the building in terms of circularity, and that allows to compare different buildings and see how is the building stock in different places regarding the circular economy. So this is the compost indicator that somehow weighs in all the different vectors into one single indicator that can be compared and can be used for certification of circularity to include as a mechanism in tenders, or could even be included for example, sustainable funding or alignment with the EU taxonomy to get certified as circular investment for building stock. So I'm explained a lot the methodological approach, which is important, but I'm gonna tell you that this is, or I'm gonna show you how this is converted into a tool and a usable tool. We did this implementation of the building circularity methodology into a web-based tool. This is just some capture of how it looks in the, let's say, the guts of it, no, the coding and programming of the tool. But it's important that we have programmed it in Python because that allows us to integrate it with different structures and different environments. And we are doing that currently with the integration of existing construction products databases, particularly one of those that Elena told a couple of minutes ago, which is BDEC, the database from ITEC, but also we are working with Madaster, which is a tool for materials passport developed by a company from the Netherlands. So I put here just a capture of it, but I'm gonna show you or switch to my the, the usable part of it, because it's better if I can show you in detail. The idea of this flow diagram is to show how a user can interact with this tool. The idea is that this circularity tool will require the end user to input a lot of data, and at the current point we have a shortcut, let's say, if the user can provide a project from ITEX BDEC, or GMA, or TCQ GMA or Madaster, then the end user will have a shorter input data phase, because most of it will be imported directly from these databases. If not, we allow the end user to manually input all the data, which is quite a few, because I mean, for a building project, you have lots of building products, with lots of informations. This is something that is then posted via API to our circularity calculation engine, and we post back the results of the calculation. So the idea is that this is something modular that can be implemented with, as it has been done with some existing products, but can be also implemented in other tools, or could be potentially implemented in a BIM environment, which would be our final aim. And coming back to my presentation, the last thing that I want to show you is how this is shown or implemented into a flexible user user experience, into a web-based tool. So in this case, I also switch to my to my presentation. Here you can see how we see that this tool would look like. The idea is that it's a tool that allows to evaluate the circularity of your building at every stage. Then you can obviously register yourself into the tool and input the different data. If you have an existing project, we can connect that, and if not, you can enter the data by yourself. Okay, and the results page would look like the one that I put in your in your in the slide deck. These are just sample graphs. The idea is that you will have like a dashboard of results in which the end user will see the different circularity in bar graphs, or in circular graph, in which it will be plotted the degree of circularity of all the vectors and the last final score, and also the loader report, with all the information. So that's it. Try to make it quick. You have my contact information here in the slide deck, so if anybody have any doubt, I will be happy to answer them as well.
Thank you, Arnau. Thank you very much. Very interesting also how we can use BIM to introduce data within this, I would say, modular add-on, not modular complement to the BIM model, so to assess the circularity score of a building. Thank you very much.
Thank you to you.
Now, as far as Andrea is not present, I will add his video. He has prepared a video explaining this Progettone app. So I will stream it directly. And then I will come in this project. Excuse me. And then we will make this round table.
Since Professor Anna Rita Ferrante and Anastasia Fotopoulos, we're working on the ProGet1 project. That is a project you will see later on for deploying exoskeleton on existing buildings to improve their energetic efficiency and their seismic resistance. The exoskeleton is afterward filled up with modular spaces. These spaces can be balconies, they can be rooms, they can be some spaces, etc. And all these rooms are a choice of the user. The user can choose which kind of room of it will have. Anna-Rita and Anastasia will tell you more about this, so I won't tell you, I won't spend a lot of time about it. So after sometimes they asked me if I could find a way to interactively show the final users or the owners of the units about an automatic way for rendering their living units according to the choices, to their customizations. At the beginning, we thought about using a photorealistic rendering plugin for BIM projects that is called Enscape, but this plugin was not giving us the possibility for rendering a scene in an interactive way and according especially to the user's choices. For this reason, we decided to use Unity, which is mainly used as a game engine, but recently is knowing a growing success in AEC, that is Architecture, Engineering, Constructions. Some colleagues are at my department are also starting to use it in the field of cultural heritage as a tool for reproducing digital twins of artifacts. Unity engine is using an easy scripting language that is called C#, and it can generate application for multiple platforms, Windows, Apple, Android, iOS, and even for the web through WebGL. So how this application work? I started to split the architectural BIM model in sub-models, which are the skeleton, the exoskeleton, and the user choices of the preferred get units. I then use a well-known and especially open source database that is MySQL to parameterize the feature of the skeleton and the exoskeleton. For example, the submodel to be shown, its size, position, orientation. Then again, I use the same DB to store the user choices about the features of their living units. For security reasons, instead of directly connecting the application to the DB, I prefer to make them communicate through a improved API that allow the communication between the two in an HTTPS layer, so it's basically more secure. Now I'm going to show you the application to make things clearer, hopefully. Okay, here we are at the login screen of the application of Get One App. So we here use our credential, the credential that we received as users, as owners of the building. I have particular credentials since I'm an administrator. The administrator can work on every flat, while the simple user can work just on one. As I press login, the application starts to communicate with the database in Europe somewhere, so it's a centralized database. And here we are brought at the Get One App project. So it is basically the test building with its exoskeleton, where all the units have been customized according to the user preferences. So as you can see, when I click on the mouse button, I can move around the scene very quickly. If I use the central mouse, at least in the Windows environment, I can zoom in or zoom out. And if I use the right button, I can pen on the scene, will stop and down like this. You see that in the right part of the screen there is this button that I can click to show the user interface. This is the part that allows the user to interact with this property. So here I can see my name, of course, because I log in as, with my credentials. I see the apartment on which I'm working. Since I'm an administrator, I'm working on the apartment 1, but I could work on this list of apartment. You see, if I select one, I'm going here. If I select number 3, then the flat on which I'm working is highlight now, and if I lose it, for example, I can press on the show button to see the apartment on which I'm working. But of course, if I would have been a normal user, I could work just on my apartment. So let's go back a little bit and let's see what these other buttons can do. Let's go in the bottom part of the user interface and let's click on the front buttons. There are 5 front buttons and 5 into buttons. So if I click on the front button, I'm brought in several positions to see which was the apartment that are centered on the apartment on which I'm working. So again, if I click it, and for example I cannot see the apartment from here, I can press again the show button to see the apartment on which I'm working. But there is also this into row, and I can click them to move around the my apartment. Okay, I'm going to the front, and let's get to the most important part of the selection, that is the get type. So for example, I can choose to change the get type to balcony, and I immediately see the results of this change. But I could also change to balcony 2, that is another kind of balcony, or to balcony 3, 4, or again for this kind of apartment that has got this size, I could also choose the type extra room or sun space. For some specific balconies like this one, I can change the parapet type to 1, 2, 3, 4, you see that the size of the holes in the balconies are changing. Sorry. But I could also customize the appearance, the materials that I use on the balcony. For example, I could choose to use laminate, and I could also change some features here in the walls, changing the colors of the walls, for example. Or again, the type of floor that I can use. When I'm satisfied, of the results, considering also the costs and the spares, the yearly spares of the particular combination, I can click on apply to save the results. Okay, so now the question is it possible to generalize this application to make it a kind of product that we can use in a different environment? Well, at this moment, this app still need some skills to export the models, the submodels, and to import them in Unity engine. Moreover, the user interface, the panel that is on the right of this app, is today designed on the specific need of this application and on the customizations that I specifically thought for this app. But once we have solved these two tasks, the answer is yes. This app could become a general product. So thanks for your attention and don't hesitate to write me. If you have any questions, please mail me at andrea.ballabeni@unibo.it.
So, thank you all of you to watch also this presentation, sorry, from Andrea about this application that can that allows the end users to tailor, to customize their buildings or the renovation works, in that case from project on a project. But I think also it can be applied to other solutions that are applied on the building renovation. So if you agree, Arnau and Elena, I have some questions for you. And also if you have any questions about your presentations, you can also talk about it. So the first would be I would say yes, but anyway, I would like to hear you. Is the BIM model of the building necessary for all the new digital tools? I would say it's the first step when we think on potential applications or digitalization of buildings.
From my point of view, I would say yes. Yes, I would say the digitalization of the building sector relies the key factor in this mixture of geometry and information model. So the BIM model is at the core of the digitalization in the building sector, because we are dealing with a physical product, and the physical product, the best way to define a physical product is by a geometry. There has never been a project since history without a geometric description and accompanied by data. Data are becoming very, very necessary, but I don't think there is any way of succeeding in building a building, a construction, without supporting you in a digital geometry model. So I would say yes. This is my point of view.
Yeah, Arnau?
Well, I'm also supporting the yes, and I would say that the challenge that we are facing in terms of critical material supply and in terms of energy intensity and the need for reduction in energy use is massive, no? This challenge, and I think that it's highly relevant or yeah, critically relevant to make use of these digital tools that we have to improve the traceability of all our materials products used in in the building construction activity. No, there's this figure that sometimes appears or points out that the building construction activities are consuming more or less 40% of our materials consumption in Europe. So it's a critical industry, and we need to trace that. And BIM obviously has the potential to trace all this information and link that to materials passport, to sustainability assessments, LCAs, and um,
Okay.
hopefully circularity assessments as well.
Yeah, great. Another question. Do you consider that the digitalization of building stock should be supported by the European Commission? I would say there are several projects that are talking already, or I would say funds, European funds that are already requesting for activities around the building passport, and how can we interact with between the real building, and these BIM models. But do you think that it's just a matter of European Commission, or we need also to get support from national authorities and regional authorities? That may be quite a tricky question.
No.
Feel free to answer.
No, I agree with you. We need everybody involved. So European Commission is always pulling, and unfortunately, in some member states are always behind European Commission. So, but I think that there are also other member states which are ahead, and I think European Commission, if European Commission and all administrations want to have an overview and to control and manage this flow of energy and circularity solutions, we need everything digitalized as a starting point, just to be aware of what we can move this part from this part. But if we don't have the digitalization of the materials, the amounts of profitability of the materials, and for example the material passports and what Arnaud was explaining, if you don't have the data, you cannot find solutions or precise solutions. So the better everything is digitalized, the more precise the solutions will be.
Thank you, Elena.
Yeah, I'm also supporting your yes. I mean, it's very important to be aligned, to work together, as Elena was saying, the practitioners, no, the end users, and also the administration. In this case, administration can push for a homogenization on the use of these digital tools. So it's an important role that they must assume, or they could assume. In this sense, and also to make easier for end users to understand the impacts of their building. I mean, in other sectors there has been this push for this kind of homogenization and the use of digital tools, and in the construction industry is still path to be done, but the context is prepared for that. So yeah, administration can do the last step to implement that.
Okay, thank you. And I have maybe a last question, which is and related to these applications that we have seen. How far are we from the market to have these kind of applications available on the market? So I know that some of them can be more or less already on the market, but regarding this kind of digitalization through BIM modeling and this houseful or circularity methodology application, are they far from market?
I would say they are far because of the usability. Let us say, when we develop tools, all of us as experts and technicians, we tend to do very complex tools that because they are generating the ideas, the complex ideas that we are working with, and the assessments and all of the indicators and everything is quite complex. And I think there is a barrier to place these tools in the market in terms of usability. They might be already available, but people don't come and see them or use them not easily because they may seem too complex to be handled. And I think what is very, very important is to make them easier to be handled. For example, the example of the render tool that we saw, I think this approaches a lot people to the tools, even because of the usability. So I would say, depending on the usability, yes, there is a barrier, and depending on it, we should solve it, because you may have built a very complete tool, a very let's say, yes, competent tool, but if it's too complex, you may not use it, no? So that's it. And we are on the way to simplify the interfaces, not the tool. The tool behind should be very complex, but when we take an electric car or we take a car today, there are not too many things to be done in the car. If you see what is behind, it's super complex. And so the very first trains, if you remember, they had lots of, or going in a plane thing, no? In a plane pilot. But we should simplify a little bit the interfaces, I would say, and this would be the success for the market.
Okay. Arnau?
Thanks. Well, I agree with Elena in that part. It's a critical aspect, and when we were developing the testing the implementation of that methodology into a usable tool, one of the main discussions that we had, and we are still trying to resolve that, is how we make it an easy to use tool, because when you want to incorporate all the data from a building project, this is quite a huge amount of data, because you have lots of small products that are all integrated into into the overall building. So one critical aspect is this usability of that, how we make easy for the end user to gather the information that we need to make all the calculations and to perform all our processes. And the other one that it's still a critical pending issue, I would say, for all these digital tools in the building construction sector, not ours, but I think it's can be extrapolated to most of it, is the lack of a single building construction products database. I mean, each countries have different databases, and that somehow the reliability of your tools depend on the reliability of your input data. So in places like here in Catalonia and Spain, where there are some built long ago databases like BDEC that Elena explained a while ago, it's kind of reliable information, but there are other places where we cannot find this kind of reliable databases, and the results that we will get from our processes and our evaluations is going to be less than in places where we have this solid database. So that's the other critical aspect for having a market usable tool that we might have to improve the information that we have available and integrate them with all these tools.
Thank you. Thank you. Very interesting feedback. So, thank you very much for explaining your experiences here. This webinar will remain in the Progettone YouTube channel. We will upload it today, and it will remain for for a lot of time there. So please feel free to watch again. And if you have, for people watching it, if you have any question, you can still send an email directly to the experts or to the project owner project, and we will answer it. Thank you very much.